Hello all, welcome to my channel. I'm back with another video. This video is part of the data engineering Snowflake series that we are doing. So in this video, we'll be going through the different options we have to select from Snowflake Compute. So let's get started. Snowflake offers many ways for us to choose a compute, and uh, a compute is something which we leverage or which we uh, use to run any computation or any kind of data operations or data manipulation operations that we have. And based on the workload, based on the type of work that we are doing, we are free to choose which on which hardware basically the uh, the operations will get executed based on the workload types. So at a higher level, Snowflake offers different type of computes. Majorly, it starts with the standard one, which is pretty generic. Then we have interactive ones, which are pretty new. These are just launched, I guess, 1 or 2 months back. Then we have multi-cluster Snowpark optimized ones. It does also has a variant of Snowpark optimized with resource constraint. Then we have Snowpark Container Service, which allows us to run containers. And then we have Snowflake Managed Compute, which is used by Snowpipe or some other services. For example, it can be query acceleration service or search optimization services. So those services also use this compute to uh, run certain workloads. So at a high level, a warehouse is a cluster of a collection of nodes or collection of compute nodes as part of a cluster that is used for running tasks or Snowflake on the Snowflake platform. And this warehouse is on demand. We can create resources. We can scale up, scale down. We can even while the job is running, we can scale and scale down. So that's one thing. And these warehouses are billable, like those are billed. They are built one per second granularity, and one Snowflake credit is something which is compute capacity to run a single VM standard warehouse for 1 hour. So that's one compute hour. So each of the different warehouses take different billings because they are running on different hardwares. And warehouses are offered in various t-shirt sizes like extra small, small, large, medium, extra large, 6S large. So these are different warehouse sizes that are available. Each of the warehouse has certain features like we can do auto suspend, we can do resume, we can scale it to 0, we can, and all the scaling happens stateless. So we don't have to worry about the data because data resides somewhere else. For example, query skills and services also, that is something we can attach to uh, certain tables. And when we run a query on that, that will be used in there. Each of the warehouses have a certain kind of a disk attached to it, which is in most of the cases it is SSD, and also they have certain memory. These SSD and memory becomes the ephemeral storage that we can use while we are running the jobs. Uh, for example, if we download something, it will get downloaded to the temp location of this SSDs. Let's say if we are trying to query again and again the same data, these warehouses can store the data which is fetched multiple times as a write through cache. Or if in case, let's say we are running some process which is running out of memory, the data that is there in the memory can be spilled to disk, and even if the disk is getting full, it can be spilled to the remote storage. So there are different options that are there for the problem storage. And so this the storage, when we are using it for cache, we can do LRU. I mean, we can do. Snowflake follows LRU eviction, that whatever is least recently used that gets evicted in case we are running out of memory or disk. So these are certain common attributes of all the warehouses. Let's talk about the standard one first. So standard one is where most of the analytics is executed. Uh, so standard warehouses has different resizing, different policies that we can attach, different resource constraint also we can provide, and then we can run on work on this. So this is how we create a standard warehouse. This is Gen 2. So there are two generations of warehouses. The difference between a Gen 2 one and Gen 2 is the hardware on which they run. Uh, so we will come back to that, but before we see, let's see other options that we have. So, for example, we create a warehouse, we say auto suspend, we auto resume, whether it will be initially suspended or not, and then resource constraint is something which allows us to add certain other attributes. Then we grant uses, and we can so warehouses we can set max concurrency, warehouse type, then suspend or resume. So there are different processes that we can do, operations that we can do on a warehouse. Now coming back to the Gen 2 versus Gen 1. So Gen 2 is the newer version which Snowflake offers. Basically, they are running on the AWS Graviton 3 instances, 3 or 2. It depends on which account, which region, and how old is the enterprise account. And they have like the hardware is different. That's what basically the changes are. So like the upgraded CPU architecture is there, faster memory and cache is there. For example, one uses DDR4 versus DDR5. Then optimized query engine is there. Better concurrency can be handled. So those are the optimization at the hardware level for standard Gen 1 versus Gen 2. And if we want to use Gen 2, we have to mention this in the resource constraint that we are looking for a Gen 2 warehouse type. Uh, then we have multi-cluster warehouses. So in a single cluster warehouse, what happens is we have, let's say if we have decided that we have small, and let's say the data that the size of the warehouse is not good enough to run, let's say parallel or concurrent resources, jobs because of the memory constraint or the resource constraint. The options that we have is to scale up or scale or run a new warehouse. In multi-cluster, what we do is we run multiple clusters in the same virtual warehouse. So one we will talk one warehouse, but it will have multiple virtual warehouses, and the jobs will go to each of these. So in auto scale mode, what happens is multi-cluster warehouse eliminates the need for resizing the warehouses because we will have multiple clusters running, so it can automatically create a new cluster to handle the extra load. And in the maximized mode, we have the control of the capacity of the multi-cluster, whereas by increasing or decreasing the number of clusters as we need. So this is how we define, like if we set max cluster and min cluster count to same, then we will go in the control mode. Otherwise, or the maximized mode, or in the case auto scale mode, we will say less than, let's say 1 and 3, minimum is 1 and to maximum is 3, sorry. So what will happen is in this case, whenever we will see there are a lot of queries which are pending, and only one cluster is running, then it will launch one more cluster and process those. And once the load is done, it will automatically scale down. So those kind of things will help us in cost effectively managing this. Uh, then we have another type of warehouse which is called Snowpark optimized warehouses. So this is for use cases where we need more memory. For example, let's say Spark kind of workload, or we are doing workloads which require more memory rather than the compute. So there is an factor like memory to CPU factor that decides different based on the size. It will decide okay how much memory we want. For example, for a medium, we can set that okay we want a memory to CPU factor as a 16. So for each core that we will have 16 gigs of memory. So that is one um, type of Snowpark optimized warehouses. So if we simply say Snowpark optimized, this will be the normal one. But if we provide resource constraint, then it becomes a constrained Snowpark optimized warehouse. And this is basically to run workload which has higher memory requirement. Then, as I mentioned, there is a recently launched interactive warehouse which allows us to run faster queries. So generally, what happens is if we have set an idle timeout on a warehouse cluster, that shuts down After that, idle period is over, and then when we issue a query, the query will wait, the cluster will come up, and then the query gets executed. So that doesn't make sense for any dashboards or real-time needs that we have. Hence, this interactive warehouse was created so that it always keeps on running. It doesn't sits means whenever it is idle, it will not go down because it has to serve the request. And also it had some other features. For example, if we attach it to interactive tables, what it does, it stores some extra metadata from the tables which are associated, so that whenever the query is coming, the queries are very fast. For example, if you make an API call powering this table using this warehouse, and the result of that will be cached on this particular warehouse. So next time when we make a call, it will not hit that actual table. It will be served from directly from the cache. So those kind of uh, metadata store is happening in interactive warehouses, and it makes the query faster. Uh, so there are these were the different warehouses, and to decide on the sizing of the warehouse, we have to think. We can start small and scale up as we did. We should be looking at automating the warehouse suspension and resumption. We have to check whether the Snowflake warehouse is under or over provisioned. We have to monitor disk spillage for keywords like bytes spill to disk. We can see it in the query insights or query profile. Snowflake query history will also tell whether the warehouse full or insufficient credit a message is coming. In that case, we will have to scale up the cluster. Query complexity on the concurrency requirements, based on that, we have to decide the right warehouse type. And also there are certain trade-offs, like for example, running a big cluster or running two smaller warehouses will make sense. So that performance versus cost trade-off we have to do, and then decide which one is right fit for us. For example, if we have an bursting scenario where uh, instead of always running a very large cluster and wasting certain resources, what we can do is we can split the workload into different smaller warehouses and allow their life cycle to be different. So apart from these warehouses, we also have to uh, managed two other options for I will say for providing the compute capability. So one is Snowpark Container Services, which runs on compute pools, which are different from a warehouse. Where it is different from a warehouse in the sense that it does not have it. It is simply a collection of certain nodes on which a container orchestration engine is run. I'm not sure, but it most likely seems that Snowflake runs a Kubernetes cluster behind the scenes on those nodes. And whenever we request a container, that gets launched in one of the nodes, and it will allow us to run custom packages. Let's say if we are doing geospatial data, we want to do GDAL or raster kind of workloads, which is not supported directly by Snowflake warehouses. We can use Snowpark Container Services. Even we can use this Snowpark Container Services to launch certain other projects like Streamlit app. We can run, like if we have requirement of running, let's say a Redis for certain workloads, we can run that Redis container on this Snowpark Container Service itself. How this works is that we have a image registry. So we first create the image registry, we build the local image, publish it to this registry, and then we define a YAML definition for this particular service, and we also decide that where it will be run, and based on that, it will launch those using that image registry, and then we will have an endpoint that we create and manage. Using that endpoint, we can start serving the queries. There is also an egress and ingress configuration that we can do. So that is something we do it with Snowpark Container Service. Again, as I mentioned, this is how we define. We first create a compute pool. We mention how many nodes, which family of nodes we want. For example, CPU. If we want, we can have GPUs as well. And then once it is created, we also create the registry. Then we create a YAML file, and then we run this run the jobs. So we have three options of running SPCS, which is Snowpark Container Service. Three modes or model we can say. Long running service, which is auto restarting. Then we have Snowflake jaw service, which is batch or one off, and then we have Snowflake service function, which is a callable endpoint for SQL mount computation. That is something that we can run. Then the other kind of compute that we get in a Snowflake environment is Snowflake managed compute, which is for this is kind of a serverless services. And for example, when we are running uh, let's say Snowpipe or search engine services, these are used by managed compute is used by those services. So query acceleration service says that it will offload certain workloads from our warehouses to this Snowflake managed warehouse, and then it will accelerate the process. Similarly, we have search optimization service that can also enhance the performance of complex queries by speeding up some of the workload. So those services use this compute, Snowflake managed compute. And this is a flowchart to how to decide which workload type will run on where. So if we have a predictable workload sizing, like we know that okay, how much memory, how much uh, CPU or disk utilization is needed beforehand, then we should go ahead with a standard one. If we don't know that and believe that it is variable, then we can go ahead with multi-cluster warehouses. Let's say if we don't, we know that the standard warehouse will work, but again, we need more memory compared to CPU. Then we have option of running either Snowpark optimized warehouse or constrained Snowpark optimized warehouses with GPU or custom RAM. But one thing is to know is, for example, multi-cluster warehouse is not the right tool for running Spark workloads. If we have Spark workloads, we should be running it with Snowpark 1. Uh, let's say if does the application that we are running require some native binaries or anything like just for example custom code. If that is the requirement, then we need a container service uh, which will run on the compute pools. And then if let's say we have workloads like snow pipe or some other task that needs to be executed, there we will have Snowflake managed compute that gets into picture. So this is how we decide on uh, warehouse type or compute type we can use in Snowflake. So this was it. If you like this video, do share it, support the channel, and keep rocking. Thanks.